In the tuning a PID controller section, the user will learn how to tune a PID controller with two methods, using manual tuning and using the Ziegler-Nichols method. In the manual tuning section, the user is given a system to be tuned using the gains of the PID controller, the proportional, integral, and derivative gain. On the left bottom corner of the screen, a reminder on how to manually tune a PID controller is given to the user with few steps. So we will use these steps to tune our system. The first step says we have to increase the proportional gain of the controller until we reach the instability point. The instability point is reached when the proportional gain of the controller is set to 9.8. The next step is to half this value at 4.9. A system steady state error is created with a proportional gain only. The steady state error is corrected by increasing the integral gain. The aim is for the center of the oscillation to be at the same level as an amplitude of 1. The final step is to increase the derivative gain Kd to reduce the overshoot and the oscillation. The aim is to reach the amplitude of 1 as quickly as possible with the smallest overshoot possible. You can also increase the integral gain a second time to correct the settling time of the system. And here it seems like the system is tuned with a value of 4.9, 2.3 and 2.3. The user can practice a bit more on the simulation using a new system by clicking on the Generate a New System push button. Each time the system is different. In the second section, the user is taught how to use the Ziegler-Nichols method to tune a PID controller. The user needs to find out the ultimate gain and the period of the ultimate gain at the point of instability. These values are used to calculate Kp, Ki, and Kd using the formulas. In the challenge, a system is given to the user, and the user is asked to input the ultimate gain and the period. The user must use the knowledge learned in the previous practice example to find out the ultimate gain period and the ultimate gain. The system reached the point of instability at 5.8, so this will be the ultimate gain of the system, and the period can be calculated by approximation or by using a data point. By measuring the difference between the two times, the period can be calculated. Here the period is of around 2.4 seconds. So when computing, the system will calculate the Kp, Ki, and Kd of the system using our two inputs and compare it to the expected values. Here we get a high score of 97%. The learning outcome of this section is really for the user to understand what is tuning, and especially with these two methods, manual tuning and the Ziegler-Nichols method, and to have a good understanding of the role of each gain when tuning a system.